Sarcopenia, the age-related loss of muscle mass and strength, is one of the most consequential aspects of aging. We're not just talking about aesthetics here. Muscle loss directly impacts metabolic health, bone density, insulin sensitivity, and perhaps most critically, functional independence in older age. Starting around age 30, adults lose approximately 3 to 5% of muscle mass per decade, and this accelerates after age 60. The problem isn't just about eating protein, though that matters enormously. It's about how protein metabolism changes with aging. Older adults develop what researchers call anabolic resistance. Their muscles become less responsive to the anabolic signal from protein intake. Essentially, it takes more protein and more leucine specifically to trigger the same amount of muscle protein synthesis in an older adult compared to a younger person. This is where amino acid timing becomes crucial. The research shows that protein distribution across meals matters more than most people realize. Consuming 30 grams of high-quality protein in one meal isn't equivalent to spreading 90 grams across 3 meals, even though the total is the same. Each meal needs to reach a leucine threshold, approximately 2.5 to 3 grams of leucine, to maximally stimulate muscle protein synthesis. For older adults, this typically means consuming 25 to 40 grams of protein per meal, not just achieving a daily total. The timing around resistance training is particularly important. Consuming protein within 2 hours after training, when muscles are most sensitive to anabolic signals, provides maximal benefit. Essential amino acids deserve special mention. Some research suggests that supplementing with essential amino acids, particularly leucine, between meals may help overcome anabolic resistance. This isn't about replacing whole food protein sources but supplementing them strategically. The plant versus animal protein debate is relevant here. While plant proteins can certainly support muscle maintenance, they're typically lower in leucine and may require larger quantities to reach the leucine threshold. Older adults relying primarily on plant proteins may need to be more deliberate about combining sources and ensuring adequate total protein intake. Now, here's the balancing act that concerns me: mTOR activation. The mammalian target of rapamycin pathway is stimulated by protein intake and is necessary for muscle protein synthesis. But chronic, constant mTOR activation may interfere with autophagy, the cellular cleanup process that's important for longevity. This suggests that while adequate protein is crucial for muscle preservation, having some periods of lower protein intake or fasting may be beneficial for triggering autophagy. A practical protocol for older adults would include consuming 25 to 40 grams of high-quality protein at each meal, ensuring meals are distributed evenly across the day rather than backloading protein at dinner, timing a protein-rich meal or shake within 2 hours post-resistance training, and potentially incorporating essential amino acid supplementation between meals. The resistance training component is absolutely non-negotiable. Protein intake without the training stimulus won't prevent sarcopenia. The protocol needs to include progressive resistance training 2 to 3 times weekly, focusing on major muscle groups with sufficient intensity to stimulate adaptation. I want to caution against the trend of excessive protein consumption some longevity enthusiasts advocate. More isn't necessarily better beyond a certain point, and very high protein intake carries potential risks including kidney stress in susceptible individuals and constant mTOR activation. The goal is adequate protein, optimally timed, combined with the training stimulus that drives muscle protein synthesis.